Hi everyone. So this is our next lesson on a hyperbola, which is the next conic section that we are going to talk about. So remember in the very beginning of learning about what conic sections is when we take a plane and we slice it through either a cone or a double cone, and some shape appears between that intersection, between the intersection of the plane and the cone or double cone. And so you can see here, that's where we are getting a hyperbola. Notice when we take this plane, slice it through a double cone, we are getting, it's intersecting with the cone twice, right? And so we're getting really what could potentially look like two parabolas. And because there's two of them in this shape, we call them a hyperbola. And that's what this next conic section is about the hyperbola. And so that's where it comes from. It comes from that intersection between a plane and a double cone. Okay. And so part of a hyperbola is that we also have two foci. And we have these foci that are formed, and you can look here. It says a hyperbola is the set of points, P, all these points on the branches, such that the absolute value of the distance between the distances from P to two fixed points, F1 and F2, called the parabola, called the foci, is a constant. Okay, and so because that's a constant value, the absolute value of the difference between 2 points is always going to be this constant value. That is where we have our foci. Okay, and so each fixed point that this is being referred to, each fixed point there is the focus of the hyperbola. We've got two focuses, we call them each foci. Okay, and so together we call them a foci, they're each a focus. Focus one, focus two, plural is a foci. And so let's, again, like we did with the ellipse, let's kind of get a drawing here, a sketch. You can see ones here a little bit already, to break down a little bit better the vocabulary, okay? Similarly to an ellipse, we can either have a horizontal hyperbola or a vertical hyperbola. So let's draw here. We can have a horizontal hyperbola or a vertical hyperbola. Okay. So it says a hyperbola consists of two smooth branches. The turning point of each branch is a vertex of the hyperbola. Okay. So our horizontal hyperbola looks like this. And where it's intersecting there, we have the turning point is our vertex. And I can do it similarly for a vertical hyperbola. We've got a vertex here and a vertex here. And for our vertices, we use the a value again, just like for an ellipse. So we've got negative a comma 0 and a comma 0. Or up and down, we've got 0 comma a and 0 comma negative a. Okay. The segment connecting the two vertices is the transverse axis. Okay, and so this is kind of why it's a horizontal hyperbola or why it's a vertical hyperbola. So for a horizontal hyperbola, we have a horizontal transverse axis that our vertices lie on. This is your transverse axis. And for a vertical hyperbola, you've got a vertical transverse axis. Here's your vertical transverse axis that your two vertices lie on. Okay. Along that transverse axis, we have our two foci that we talked about earlier, which is how a hyperbola is really formed. And so we've got a foci here and a foci here along the horizontal transverse axis. Same thing here. We've got a foci here. Oh, really, these are focuses because they're singular there. Okay? And we use the same variable as we did before. We use a variable c to denote a focus. So I've got negative c comma 0, c comma 0, 0 comma c, and 0 comma negative c for that focus. Okay? So all of these key features lie on that transverse axis. And what we want to show, let's see, we'll keep going here, and you'll see what we just drew. The same thing for a horizontal and the vertical hyperbola. What you'll see that we haven't drawn in just yet is the b value. And maybe you were starting to think about, well, if an ellipse, there was a b value. And so we still have a b value because it's in our equation. So let's take a look at our equations here. I'll zoom in. Our b value comes into our equations. And they're similar to an ellipse. So a horizontal hyperbola equation is x squared over a squared minus y squared over b squared equals 1. And the big difference here is now we're subtracting. And also that a value does not need to be the largest. What is going to be the difference here between these two forms, if you can notice already, is where the x squared and the y squared is. So for a vertical hyperbola, that y squared is first. And that tells us that we have a vertical hyperbola. We have a vertical transverse if that y value is first. If the x value is first, we have a horizontal hyperbola with a horizontal axis, horizontal transverse axis. And notice then that all of my key features are on the x values. The vertices are on the x values, the foci are on the x values. For a vertical hyperbola, we have a vertical transverse axis. Vertical is the y values. Our vertices are going to be on the y values, and then the foci is going to be on the y values. Notice our formula to find the foci is a little bit different. It's exact than it was with an ellipse. It's exactly Pythagorean theorem. And how we're going to use this b value, right? Because notice the b value is in our equation. The b value is going to help us create the asymptotes that these branches go along. So if you remember, an asymptote is a line that the function approaches, it gets really, really close to, but it never touches. And so that's ultimately how these hyperbolas are formed, because we have these asymptotes that the branch continues to get really, really close to, but never touch. And so how we find those asymptotes, because they're a crucial part to drawing a hyperbola, is by using the b value. Okay, and the b value tells us how far we're going to go on the axis perpendicular to the transverse axis. So here was your transverse axis. The b value tells us how far we're going to go up and down. Here's your transverse axis. The b value tells you how far you're going to go left and right. And then we draw this rough sketch of a box. You can see the green box that's drawn in. And that green box helps us draw the diagonal asymptotes. And ultimately, we need those diagonal asymptotes to draw the hyperbola. And that's where the b value comes into play. And so I want to give us a couple steps here that are going to be helpful when drawing hyperbolas. The very first thing, let's jot down some steps. Oops. Very first thing is we want to use the a value to plot the vertices. We can obviously then also plot the foci. Our second step is to plot the B value. And that goes in the opposite direction on the opposite axis. Our third step is to draw the box. Formed by A and B values. And then your fourth step is to draw the asymptotes using the diagonals from box. And then you can draw your branches. Okay? And so we're going to use those steps to write the equation here and to graph this hyperbola for problem 1. So let's check it out. It says we have a hyperbola centered at 0, 0, so at the origin. And we have vertices at plus or minus 4, 0, and 1 focus at 5, 0. Okay, so when we look at our vertices, so let's write down, we've got a plus or minus 4, 0 is our vertices. So that tells me that our A value is 4. And then because we have a focus at 5, 0, I know my C value is 5. Right away, I'm realizing I'm going to need to find my B value. So let's use our equation, C squared equals A squared plus B squared to find B. So our C squared is going to be 25 equals our A squared is 16 plus B squared. We're going to get, subtract 16, we get 9 equals B squared. So now I know my B is 3. And this is all helpful information to help me plot the hyperbola, to help me graph it. As soon as I realize that my vertices are in the X value, I know I have a horizontal hyperbola with a horizontal transverse axis. And so let's go ahead and we will start to plot everything. And so I've got my vertices, my origin is at centers at the origin. I've got a vertice at 1, 2, 3, 4, 0, and 1, 2, 3, negative 4, 0. I have a focus at 5, 0, and negative 5, 0. Important to graph. So we need to have them on our plot, our coordinate plane here. And now we're going to plot our B value. It's on the opposite axis than our transverse axis. Here's our B values. And now we're going to draw that box formed by our A and B values. So I'm going to draw this rough sketch. This is not like a part of the graph, so it's very light, but it helps us get our asymptotes, which we need for the graph. And then we're going to draw our diagonals, which are our asymptotes that go diagonally through this box. So I've got here, and there's one asymptote. And then here is my other asymptote. And so that's crucial because now I can draw my branches that go through my vertices and along my asymptotes. My vertices are on that horizontal transverse axis. Here are my vertices, if you remember, at negative 4 and positive 4, 0. And when we draw our branches, are you ready? They go along the asymptote through the vertice. through the vertex. I'll do the other branch. Along the asymptote, do that one again. Along the asymptote, through the vertex. Okay, and there we have it. This one's not great. I'll do this one again. Along the asymptote, through the vertex. Okay, and so everything that's in blue there is the graph of this hyperbola. Our vertices are plotted, our foci are plotted, our two branches are plotted, and we couldn't have done this without those two asymptotes. So the two asymptotes are really important. And we couldn't have gotten to the asymptotes without drawing the box, which is why I needed to find the b value. Okay, and let's do one more here. It says, oh, actually, I don't think we wrote the equation. Yeah, we need to still write the equation. Our equation, it's a horizontal hyperbola. And so our horizontal hyperbolas have the x squared first. X squared over your a value, which is 4, so 16, minus y squared over the b value, which was 3, so 9, equals 1, is our equation to that horizontal hyperbola. X squared is first, that's what made it a horizontal hyperbola. Okay, now let's check out this example 2, which is the last example in the video. What are the vertices, foci, and asymptotes of the hyperbola with this equation? 9y squared minus 7x squared equals 63, and sketch the graph. So first we need to get this into standard form, which we're used to from when we looked at ellipses. So we've got 9y squared minus 7x squared equals 63. Divide both sides by 63 to tell us our equation, at standard form equation of this hyperbola, is y squared over 7 minus x squared over 9 equals 1. Right away, when I look at this equation, I know it's going to be a vertical hyperbola because that y squared is first. Okay, then we're going to go ahead and check out our, let's see what's next, our vertices. So looking at this equation, I know my a squared value is 7. And I know so that means my a is going to be plus or minus 7. So that means my vertices are at 0, comma, plus or minus the square root of 7. I know that because I know it's a 0, comma, because it's a vertical hyperbola. So it's going to go up and down on a vertical transverse axis. And then I've got my b squared is 9, so my b is 3. And that helps me graph this. Doesn't give me a piece of information, just helps me graph it. I still need to find my foci, so let's find the foci by doing c squared equals a squared plus b squared. C squared equals, my a squared is 7 plus my b squared is 9. So my c squared is 16, so my c is 4. That tells me my foci are at 0, comma, plus or minus 4. Again, it's along that vertical transverse axis. Okay, and so now we can start to put this together on a graph. This is roughly 2.6. I want to mark that. And let's graph. My foci are at plus or minus 4, and my vertices are at plus or minus 2.6 about. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2.6 and negative 2.6. I've got my vertices. And then at 4, I've got a foci. 4. And now we're going to draw in plot our b value. 1, 2, 3. 1, 2, 3. Which is going to help us draw this box. Which is then going to help us draw the diagonal lines which are the asymptotes of the hyperbola, which I need to write the equation of these asymptotes. So I want to write the equation of these asymptotes after I draw them. And I'll talk about how we're going to write the equation of these asymptotes. Okay, and so let's write the equation of that line. And what I want us to think about before I tell you the shortcut definition, we know that's going to be an equation of a line, y equals mx plus b. The b is 0 because the intersects at the origin. So y equals, I just need the slope. Okay, and so my slope here, let's look at our rise over our run. Our rise is square root 7, and our run is just at 3. And so the equation of these asymptotes, or where we can find our asymptotes, are at plus or minus square root 7 over 3. And if you caught this earlier, awesome job. It's always going to be plus or minus a over b, because x, we need that for our equation of a line. Okay, here's your slope. It comes right from there. That's what we did, our rise over our run. Okay, so put the x in there. And that's just from a over b. You can see your a value and your b value. Okay, and so let's finish this by drawing our two branches that go along our asymptotes and through the vertex. Along the asymptote and through the vertex. Along the asymptote, through the vertex. And so here you can see in red are all of those key features that we need graphed. And we were able to graph all of those correctly because we had our dotted asymptotes in there, which will need to be shown as well. Okay, great job, guys, learning all about how to draw a hyperbola. If you have any questions, please let me know. Awesome work.